All right, we're powering through. We're going to do Chapter 10, Section 4. Sorry, all my fractions got, I don't know, they disappeared. But anyway, what we're starting to do now is graph our conic sections. And yeah, I think that's pretty straightforward of what we're doing. I think it's certainly helpful to rewrite with the 0 in there, rewriting 9 as 3 squared. The plus is indicating that we are going to have an ellipse, and 16 is 4 squared. And we'll worry about the less than or equal to 1 when we get to it. So what I'm getting at is that you should recognize that the center is at 0, 0. And then your A value is 3. So from that origin, we're going to go, because it's under X, to the right 3 and to the left 3. Now those are not your vertices because the B value of 4 is larger. So from the center, underneath the Y, we're going to go up 4 and down 4. And so now let's talk about what kind of line we have going on. Now you may remember when we had that or equal to from an earlier unit. That was our clue that we had a solid line. Let me write that down. Solid. Instead of a dashed or dotted line for our ellipse or for our curve. Might be a better way of saying that. So if it's just less than or if it's just greater than, we would have a dashed line. I'm not sure if we even have one. There's one. So we'll get to that one when we get to exercise 3, apparently. And I can play with Desmos and show you exactly what would happen then. And then the next thing that you need to recognize is, are we shading inside of this ellipse or are we shading on the outside? Now, instead of teaching you a shortcut, I think it's best if you just picked a random point. So a random point that's either inside or outside. And it either works, the point either works or it doesn't work. So if the point works, shade inside of that region. So it makes the most sense to plug in 0, because 0 to any power is 0. Divide by 9 is still 0. Same with this 0. Plugging in 0 and 0, that's why I put a point at the center on this problem. And is it true that 0 plus 0 is less than or equal to 1? Yes, that's true. So where do we need to shade is inside of our ellipse, because the point that we selected was inside and it was a point that worked. So any point that's inside that ellipse will work. And if you don't believe me, pick a random point that's on the outside, and you can make it even a ridiculous point, like the point 10, 10. And again, I'm picking a ridiculous number because 10 squared is 100 divided by 9 plus another 100 divided by 16. A very large positive number plus another large positive number is going to be a number bigger than 1. So that's not going to work. And since that point doesn't work, you don't shade anything on that side. So just to prove my point that we have the right graph here, I'm going to just show you with Desmos. What I like so much about Desmos is it will literally give you the less than or equal to symbol, and it shades for you. So I'm not trying to just tell you to just cheat and just use Desmos, but this is a good teaching tool, because what if I change that from less than or equal to less than? See how it makes a dashed line? What if I change that to a greater than? See how it shades on the outside? Change it to a greater than or equal to. Oops, I guess I need to delete that one first. Now it's a solid line on the outside. Dash line, solid line. But anyway, the correct one that we wanted was this one, so I did this correctly. The only thing Desmos does not do is tell you what the center is, and if I'm being perfectly fair, I didn't even label my center. I mean, I wrote it down, but I didn't label it. Yeah, so Same thing could be done on the next problem. And we actually did problems like this one before, and for whatever reason the book wants you to use a graphing calculator. But just as a reminder, this is vertex form if you wanted to add the -0 in there so that you can see the vertex. Probably feels like a long time since we've done this. Is right 0 or left 0 up 2. I'll scroll down a little bit. So just a reminder that that is your vertex, opposed to up here, the vertices were along the major axis of the ellipse. On this problem, the vertex is right here. Solid line, because it's or equal to. And this time, where are we going to, well, it probably makes most sense to pick 0, 0 again. Easy numbers. Is it true that 0, for y, is less than or equal to 0 squared plus 2? Yes, it's true, so you need a shade below that curve. I'm just using a highlighter to shade our region. But again, a graphing calculator will give you the correct answer, especially Desmos. Let me just hide that real quick and just type it in, less than or equal to x squared plus 2, and you can see exactly what our curve looks like. So again, I want to see your vertex, as well as do you have a solid line, and did you shade correctly? That's what I'm looking for. So probably been a while for you since we've done problems like this, and I'm aware that it says to double check with a graphing calculator, but let's practice without a graphing calculator. So what I would do is I would subtract that 9x squared over here. The inequality is still greater than. And I guess I should point out that the only time you switch that inequality is if we divide by a negative. Well, in this case, we're going to divide everything by a positive 144. And if you're sitting there and you're wondering why we're dividing by 144, is you may recall that on a hyperbola problem like this, we want it to equal 1. Well, in this case, it's greater than 1. And if you reduce, I think you've probably noticed the pattern that 16 times 9 gives you 144. So 16 goes into 144 9 times, and 9 goes into 144 16 times. And it might help you as well to write it out as y minus 0 squared over 3 squared minus x minus 0 squared over 4 squared is greater than 1. So where are we located? Our center is at 0, 0, 0 for the x-coordinate and 0 for the y-coordinate, so we're at the origin again. This time my b value is written first, is 3. So as I go to the graph of this, because the b value is positive, so my center's right here, and it's underneath the y value, that's where your vertex is located. It's not the larger number, because the larger number is this one, because this is the negative. So there's one vertex. There's my other vertex. And if you remember, I asked you to make a box. 2, 3, 4, 1, 2, 3, 4. So our picture is going to get a little messy. But the box is helpful to see how spread out your hyperbola needs to be. Because as we draw our diagonals that go through the box, and again, I'm using a light color because it's not your final answer. The final answer I'm going to do in black. We have our vertices, and so that's telling me that we have an upwards and a downwards hyperbola. Notice that I'm doing a dashed line for my hyperbola. Why am I doing a dashed line? It is not equal to. So that's our dashed or dotted curve. And in this case, it's a hyperbola because of the minus, as I mentioned earlier. So right here, dash going this way. And notice that it's not in the shape of a parabola. It's not quite that U shape. And every problem's a little bit different. So again, I like Desmos. Oh, I'm not even done. Sorry. I was about to jump to Desmos. Is you also have to pick a point. I still think it's to your benefit to pick 0, 0. Because if you plug in 0 for x and 0 for y, I think it's pretty clear that anything times 0 is 0, and over here is 0 plus 144. Is it true that 0, I'll write it right here, is greater than 144? No. So therefore, that point is not part of the shaded region. So where are our regions? We have a region up here, which does not include 0, 0. And we also have a third region down here that does not include 0, 0. And this might make more sense if I pull up Desmos, which of course I'm gonna do. And we have this middle region. And this part with my box or my slant asymptotes just helped me create a better graph. So now I'm satisfied with my answer. I'm going to pull up Desmos to clarify what my correct answer is. So again, let me just close that out. I think it was 16y squared, yep, is greater than 9y where's my squared plus 144. Whoops, I didn't make it x there. Whoops, I knew there was something wrong. So let me hide that so you can see. So I think now it's pretty clear what I meant by three regions. There's a region down here, there's a region in the middle that includes 0, 0, and then the region up here. So if this were a different problem, let's say it was less than, see how the 0, 0 would have worked, and we would have wanted that middle region instead of the top and the bottom. And by the way, this is not really the easiest stuff, so if you have questions, please, please, please write them down and ask me. And notice if I change that greater than to an equal to, all it does is changes it to a solid. But we want the dashed in this problem. This is probably a good place to stop for my video. We're almost 13 minutes in. Just to give you a heads up, I still have to have you graph systems and find where they overlap. And we have 2 of those exercises. And for whatever reason, this didn't show up very well, but it is stated in your assignment, whether it's Google Slides or on the Google Classroom assignment page, that it's 4 through 36 multiples of 4. So if you want to get started now, that's fine. 4, 8, 12, 16, 20, 24, 28, 32, and 36. So I'll see you in the next video to do exercise 4 and 5.